Hello, welcome to the video. In this lesson, we're looking at section 5.1, where we're going to be solving systems of linear equations by graphing. There are uh, three different ways that we can solve for a system. Now, a system is when we have two separate equations and we attempt to find, if there is any, we try to find the point of intersection from the equation. All right, we can either do it by graphing, we can either do it algebraically. All right, the most challenging way to do it is through graphing because you have to be really precise with it. So when you are graphing, it is extremely recommended to use a straight edge while you're graphing to make sure you're as accurate as possible in order to obtain the answer that you are looking for. So the thing that you have to keep in mind is when you get a solution, when you get an ordered pair, it must it must work for both equations. So in these two examples, we have two separate equations. We got equation 1, we got equation 2, and we have an ordered pair of 2, 5. Now, in order for this ordered pair, 2 comma 5, to be a solution of the system, it must work in both equations. If it only works in one but not the other, it's not a solution. It has to work in both. So looking at equation 1, I'm going to say, okay, so this is my x coordinate, this is my y coordinate. Can I say that 2 plus 5 equals 7? Is that true? The answer is yes. So it satisfies equation 1. Now I need to see if it satisfies equation 2. So I got 2 times 2 minus 3 times 5, and I want to see if this equals negative 11. Well, this 2 times 2 is 4, minus 3 times 5, which is 15. Does that equal negative 11? The answer is yes. So since it satisfies both equation 1 and equation 2, I can say yes, 2 comma 5 is a solution. Looking at example B, same thing. This is my x, this is my y. Let's see if it goes for equation 1. So y is 0. This is going to be equal to negative 2 times it by negative 2 minus 4. So 0 is equal to 4 minus 4. Yeah, 4 minus 4 is 0. That's yes. So let's look at equation 2. So now I got 0 is equal to negative 2 plus 4. Is 0 equal to 2? The answer is no. So it did not work for equation 2. So in this particular instance, negative 2 comma 0 is not a solution to the system. And this is a way that you can check your answer from the graph. If it doesn't work, then we can state that we might need to try another point or maybe recheck your graph to make sure that you graphed it correctly. So here are the steps that we need to do in order to solve a system of linear equations by graphing. The first step, it says graph each equation in the same coordinate plane. From there, we are going to get hopefully an intersected point. If we do in fact get an intersected point, we're then going to check that point just like what we did in the previous two examples in our notes. So here's our two equations. I got y is equal to negative 2x plus 5, and I got y is equal to 4x minus 1. They're both in slope-intercept forms. That's great. We can go about solving it from there. The first equation, my y-intercept is 5, so I got 1, 2, 3, 4, 5. Plot the point. And then my slope is -2, so it's down 2 to the right 1, down 2 to the right 1. And what I'm going to do is I'm going to make several points because, again, I want to be as accurate as possible when I make this line. And I'm also going to go up to the left one, up to the left one. So grab my straight edge, and I want to make sure that it hits all of the points that I created from the slope. All right, so that looks like it's pretty good. It intersects all those points there. Now I'm going to look at the next equation, the second equation. So it looks like it's at -1, and it says 4 is my slope, so it goes up 4. 1, 2, 3, 4 to the right 1. 1, 2, 3, 1, 2, 3, 4 to the right 1. And this is nice because one of the spots seems to already intersect, so we can kind of use that as our point of intersection. So it appears that the point of intersection is located at, looks like 1 comma 1 2 3. All right, now you let's take a look and see if it satisfies both equations. So looking at equation 1, y is 3, so I got 3 is equal to -2 times it by 1 plus 5. Well, -2 times 1 is 2. Does -2 plus 5 give me 3? The answer is yes. Looking at equation 2, I got 3 is equal to 4 times it by 1 minus 1. 4 times 1 is 4. 4 minus 1 is 3. Yes as well. So 1 comma 3 is in fact our solution. Okay, so let's look at some other ones. So let's look at number 4 because it has some fractional slopes. We'll also look at number 5 because they're not both written in slope-intercept form. So with number 4, I have a y-intercept of 3, so I go up 1, 2, 3, and then I plot the point for the slope, which is 1/2, so it's up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, and I just make a bunch of points in order to satisfy and be as accurate as possible. And looks like I have enough to make my line, which would be somewhere right in here. And the hopes is that you can, at least with the slope, be able to intersect it. So it goes 1, 2, 3, 4, -5. 1, 2, 1, 2, 3, 4. -5 is right there. Sorry. And this one is -3/2. So it looks like down 3, 1, 2, 3 to the right 2, or I'm going to go up 3, 1, 2, 3 to the left 2. And this is probably a better option because eventually we should be able to intersect 1, 2, 3, 1, 2, 3. Oh, good. So we got an intersected point from doing the slope a bunch of times. And it looks like it's right here. And it appears to be -1, -2, -1, -2, -3, -4, comma 1. That seems to be our solution to this system. And again, let's take a look at number 5. Number 5 has 2 equations, both of which are not in slope-intercept form, so I'm going to subtract 2x to both sides to the first one, so I get y is equal to negative 2x plus 5. And for equation 2, subtracting 3x to both sides, now I got negative 2y is equal to negative 3x plus 4, dividing negative 2 to the entire equation. So my second equation is y is equal to positive 3 halves x minus 2, because you got to change the signs with that negative 2 on the bottom there. So with that, looking at the first equation, looks like 5 is my y. 1, 2, 3, 4, 5. Plotted that point in negative 2, so down 2 to the right 1, down 2 to the right 1. Again, creating a bunch of points here to make the most accurate line for the equation. I'll also go up to the left one, up to the left one, and take my straight edge and looks like I'm pretty close with all of those intersected points. All right, now hopefully, just like I had in the other ones, hopefully I can create an intersection with that point. If not, we'll see what happens. So it looks like 3 halves, so it looks like it's up 3, 1, 2, 3, to the right 2. That's great. I got a intersected point, but I'll go up 3, 1, 2, 3, to the right 2. I'll even go down 1, 2, 3, to the left 2. And I have enough information to make my line. And it looks like it appears that they intersect at 2, comma 1. And again, I would advise you to check those answers to make sure that those answers verify those equations. And that is being able to solve systems of linear equations by graphing. Hope this helps. Until next time.